This is a video for MEI Core Pure Mathematics, Vectors 4, Lines and Planes, 4.2, the angle between a line and a plane. If we have a look at this diagram, I've got here a plane with its normal vector here, and I've got a line with a direction vector here. And it's very difficult to work out the angle between those two. I'm going to draw on an extra couple of bits to help us out. So the first thing is I'm going to put on a plane that contains the normal vector and the line. So that's that pink section there. And if I then draw in the line in the plane where the two intersect, you see I get this line here, and the angle I want is this angle here, theta. The problem is that it's quite difficult to determine this line without solving an equation for the two planes. However, I know all about the normal vector and I know all about the direction of the line. Therefore, I can find this angle, the angle between the direction of the line and the normal vector, and I can get that from this relationship. The dot product of the two is mod d mod n cos alpha, where alpha is the angle between them. And because this now is just a right angle, alpha and theta are complementary, so the angle I want, theta, is just 90 minus alpha. So let's look at an example. I've got a plane pi, here's its equation, and I've got a line L, and here's its equation, and I want the angle between them. Now, this does actually ask us for the angle. Sometimes it will ask us for the cos of the angle between them, but we have actually been asked for the angle, so we are expected to get something in terms of degrees by the end. Well, from this, I know that my normal vector is equal to 2 minus 1, 3. And from this, I know that my direction vector is equal to minus 1, 2. So now I can plug it into the formula that we saw on the previous page, which was that n dot d is equal to mod n mod d times cos alpha. And rearranging this, I'll get that cos alpha is equal to n dot d divided by mod n mod d. And actually we saw that in a previous video looking at the angle between two lines. Plug in the values, then we'll get 2 minus 1, 3 dot minus 1, 2 all over, well, if I look at this, I'm going to get 4, 5, and 9 is 14, so I'm going to get root 14 for the mod of n, and here I'm going to get 1, 1, and 4, so root 6 there. Do the dot product, I get minus 2 plus 1 plus 6, and of course that's all over root 14 root 6, and that gives me 5 over root 14 root 6. And if you plug that into your calculator and do the inverse cos, you get that alpha is about 56.9 degrees. And that means that theta, the required angle, is 90 minus that, which comes out at about 33.1 degrees. There's that working, written up tidily. So you can see here I've used the cos alpha is n, where that's the normal vector extracted from here, dot d, where that's the direction vector extracted from here, over the modulus of each. And that comes out to my 5 over root 14 root 6, as we saw on the previous slide. And there's confirmation of the angles, alpha 56.9 and theta is 33.1. So finding the angle between a plane And a line is actually no different than finding the angle between two lines. Instead of using the two direction vectors, you use the direction vector of the line and the normal, as we have done here, and then do 90 minus that, the complementary angle for that, to give us the angle between the line and the plane. That was the final video in this sequence, Vectors for Lines and Planes.